I was here the first CF camp. I was invited by Mishi and Chris, and they've always been gracious hosts, taking in this Salvadorian and coming here. So it was always great. So I love this conference. And now I get to do my third keynote in, 13 years or something here? So very excited. So today, the topic is The Future is Dynamic. My name is Luis Majano. I'm the CEO of Ortus Solutions. My background is a computer hardware engineer. I've been called many things, from Mr. Box to documentation weirdo to many other things, especially by my friend Mark Drew, which I like. I was born in El Salvador, and I currently reside right now in Spain. I always start with a joke to kind of break the ice. Everybody's nervous the first time, so my kids always want me to do a dad joke. So what do you call an anxious dinosaur?
What?
Thank you, Brad. A nervous Rex. All right. It's recorded. My kids can be happy now. So a year ago, in CFCamp of last year, we presented a project that we had been working on called BoxLang. I can very happily report that that initial idea that we started a year ago is now stable. And we released our first version in DC a few weeks ago. It was a 1.0. And we already found a lot of bugs. So, okay, 1.2 coming. So as this traverses, we're very, very excited about this project, and we'll tell you a little bit about it. Here's the team that have been working very hard on BoxLang, from people in Switzerland to Spain to El Salvador to the US. So this has been really a collaboration between everybody at Ortus. And it's been very exciting. It's been really the most difficult thing we've ever done. It's not a small undertaking. We've basically done this for 20 months. The last 20 months, we released 27 betas, 3 release candidates, and now 2 minor updates. We've had a collection aggregate of over 12,855 automated tests. Brad wanted the real number. So it's been a real testament of providing continuous integration for the language. We already have over 52 related repositories, 33 released modules, over 20 contributors, and the reality is that we have just only started, which is very exciting. So, announcing a few things is that we started a new community repo called BoxLang Community CI. This is a work in progress. We actually released it yesterday, and this is a way for anybody that has any type of open source project can actually come in here and add not their code, but a way to actually automate their tests against our bleeding edge. And this will actually allow you to provide a snapshot if we have made a mistake and your project has regressed in any version of our language. So this will really help us out. So if you are the maintainer of an open source project, come aboard and help us out. We started this story, obviously, with a lot of history in CFML. Our CFML parser, as we'll discuss a little bit of how we did this, we claim a 99.9 because we never know the edge cases like we discovered yesterday. We went through core bits and core tags. We consider those core to be complete as well. All the Ortus major libraries are compatible: ColdBox, TestBox, ContentBox, and over 300 open source repos that we manage. Obviously, if there's anything else, just let us know. The transition for us has begun. We're migrating everything now that we're stable. Migration is really easy if you're in CommandBox. You can actually just change the CF engine, make sure you're on JDK 21, install the modules that you require. If you want a new project, you don't use the compat CFML, but if not, you use the compat CFML, and it will basically allow you to run your CFML applications in our runtime. With this initiative, we not only wanted to stay where we were, but we really wanted to go where we always wanted, and that was the Java world. So this year has been really incredible for us, as we've been able to attend many Java conferences already, including JFocus in Sweden, DevNexus in Atlanta. And it was great to basically be with over 2,000 people presenting BoxLang. I presented on Lambdas, on serverless. This was a big attraction for Java developers to release their applications in BoxLang to the cloud. People were actually coding on their phone and winning awesome hoodies. So it was really exciting. Brad always never removes the hat.
I sleep in it.
So he has a big hole right here. But it was really exciting to be able to share. Brad did an interview with a famous podcaster in DevNexus, which was really hilarious. So it was really exciting to be able to attend to these conferences and really represent and get an insight from another world. And we haven't stopped there. We're speaking at other 3 conferences in the coming weeks. In Malaga, Open South Code by my friend David Cedeño. He manages an amazing open source conference in Malaga. DevOps coming soon in fall, and DevBCN in Barcelona. So we're very excited to be promoting as we go, updating BoxLang. So a year ago, we presented a bunch of things, and we have a lot more things to present on, especially a few key updates that we've been working on as we traverse. So BoxLang, when we started this, the idea is to start at the smallest idea possible, which is embedded systems. So we decided that we wanted this to run at a chip level. And that's how we actually ended up writing BoxLang Core, which is about 7 megabytes in size, and to run basically at the operating system level and be able to manage any type of embedded system. That was our first runtime. And then we wanted to make this multi-runtime. So each runtime basically aggregates upon itself and discovers new items and new things that are available to itself. So then came a mini server, then came command box, of course, WAR, then came Docker, then we actually created an LSP, a language server protocol for VS Code. We created Azure functions, Lambda functions, and more that are coming. So the idea was for us to start with the smallest possible language and then being able to define hierarchically different runtimes that it could execute and deploy. And we haven't stopped, so we have more that we're working on. I'll give you a sneak peek at our Electron runtime today. And next, we're working on a Java FX, which is similar to Electron, but purely Java-based. Then we're finalizing Google Cloud Functions and Azure Functions and Apache OpenWhisk to do more cloud functions on different providers. And we've already started to integrate with GraalVM. We actually met with the GraalVM team a few months ago, and we're going to be doing a lot of things with them in order to integrate other languages into BoxLang, such as JavaScript, Python, WebAssembly, and Ruby, that you're going to be able to run natively inside of BoxLang. So it's very exciting. We also launched last year our concept of how do we start coding, right? So it was try.boxlang.io. It has gone through many iterations now. You can try it. It was our first production application for BoxLang. It's powered by multiple runtimes, by our mini server, by Docker and Lambda. We can now add code sharing. You can link, you can embed this in your applications as well. It now has an error viewer. It has UI updates, keyboard shortcuts. And really, it's the best way to kind of just start playing around. It's been really exciting. It's also been an eye-opener of how Lambdas are very powerful. We get average executions of about 28,000 Lambda executions per day. Our average execution time is about 38 milliseconds. So runtime starts extremely fast and be able to provide all this traffic very, very nicely. So they scale and contract as we need them. And the most important thing for us was that we pay zero. That was most important. Amazon gives you about 1 million requests for free. So it's amazing to know that we're still in the free tier. But we are not stopping there. We're doing more integrations for you to be able to embed this in more documentation. We're working on code lessons, the ability to have multiple versions, web runtime, so you can actually do web stuff inside of Try, and VS Code integrations. And I'll be doing a session tomorrow on Lambdas if you're interested as well. So that one was a big success for us. The other one we did a lot of strides for and a lot of our client needs was scheduling and the task framework. This started with ColdBox about 3-4 years ago, and now it's just part of the language. And you can actually write your schedulers in BoxLang and Java or both. You can actually run them at the CLI, so you can completely replace cron. You can run them in web, or you can even run them in Lambdas. You have the concept of global schedulers or application-specific schedulers. All very easily and fluent and writable. They're highly configurable. You can even choose which thread pool or executor service you want to run them in. You can bind it to a specific distributed cache to do distributed locks and distributed tasking. Here's where you can define your schedulers, and we're working on imports as well. and defining tasks at the configuration level. Lots of new interactions for you to work with schedulers, from restarting them, starting them, getting statistics from them, shutting them down, etc. So we're already building a lot of dashboards based on all this functionality available to you now. And more is coming. Server fixation run by environments, Adobe and Lucy imports, database-driven tasks, and of course we're building a whole monitoring tool so you can actually see all of your tasks that are being deployed in your applications. So it's a brand new way to actually work with tasks by code. We finally released all the Docker containers as well as a part of our runtime strategy. We have our command box container now available for BoxLang and its stable versions, all based on Java 21. We have a mini server as well. This is what powers BoxLang. Super fast, super lightweight, excellent for debugging or even running one-off commands, but it's a very lightweight, incredible server. I'll give you a demo today if possible. And of course, the CLI one now available. So you can use this as a Docker container just to create scheduled tasks or actually execute code. Of course, we have to mention AI, right? Everybody does, why not? So we released actually our first iteration of BoxLang AI. We've been studying this on how to approach it for a long time. And what I really wanted to do is actually do an encapsulation so you can actually code against interfaces and abstractions instead of really just committing to a specific provider. So now we've actually created the BoxLang Abstraction API. You can actually work with all those providers that you see there, from Claude to Perplexity to DeepSeek to Grok to Gemini, OpenAI. And the idea is for you to not change your code. Is you change your provider, but at least your code remains the same. So it gives you ability to build messages, very complex messages or simple messages, compose chat requests, you can do and asynchronous requests as well. So very easily you can chat with any LLM. You can use those new BIFs, AI chat, chat async. This is all part of a module, not the core. Chat requests, AI services, and for us, a really important one was tooling as well. But you can also do asynchronous chats. You can actually start conversations and then pick up the results whenever you need. So you don't have to even be waiting for the chat response to come immediately. You'll get a box future on that. This was the most interesting one, was to actually connect people's applications to the LLMs in real time by asking real-time information that only your systems will know about. So very easily you can actually define a closure that points to any CFC or whatever you want and basically define how your LLM should interact with. So if you say how many orders have been done today, you can actually respond with the orders, or you can send a JSON packet of all the orders. And very easily, you can now integrate conversations with any LLM and be passing these real-time information to them. And there's more coming. We're starting out part of our subscriptions as well: audio generation, text-to-speech, image generation, chat memory, and a lot of things that are on the works. This was just our start. We also announced Mr. Raymond Camden. Do you guys remember Mr. Ray, our CF Jedi Master? So Ray has been awesome. He started working with us as a BoxLang advocate last year, actually this year, sorry. And it's been really exciting to have him on board with all the ideas that he has and the amazing capability to find bugs. And we started a collection of demos, which is called BX Demos. You can find it under Ortus-BoxLang. And he's been going at it. So you'll find thousands, well, not thousands, that's my Latino. Okay, hundreds of demos there. Millions. But a very nice resource. And if you have demos or stuff that you want to contribute, please do. I really wanted to bring Ray. Unfortunately, we couldn't make it happen, but he sent a video to you guys. So I just want to put Ray to send you a nice hello.
Hi, CFCamp. I really wish that I could be out there this year. All I know is that Luis better darn well find a way to get me out there next year so I can join y'all. I am Raymond Campton. I am a BoxLang evangelist, and I'm really excited to be able to take part in the launch of this new language. BoxLang is built from the ground up to be small, quick, and what I appreciate the most, really darn flexible. It supports building CLI tools, serverless function, web apps, and more. And even better, it's a fun language to play with. So download it today, check out our docs and samples, and join our Slack if you have any questions, or even better, if you want to show off something cool that you have built. Hope to see you there.
So that's Ray. So he was very kind. Hopefully he'll be here next year. He said the only way to get here is somebody provided a Jedi Master sword or something. So he's a picky one. But anyways, I want to give it to Brad so he can talk a little bit about what we've done with the language.
Awesome. Good morning, everyone. I don't know where to put my phone. Put it in my pocket. It's so great to be back here at CFCamp. I love all the faces here that I don't get to see at the U.S. conferences. Okay, so it's been a year since we talked about all this great stuff. One of our core features that we kind of had in mind for building BoxLang was what we kind of call the BoxLang framework, and that is how we architected the internal portions of BoxLang. So we have a collection of services, basically, that are all part of the BoxLang core. We have the application service, the asynchronous service, the cache service. Components are what we call tags now, trying to move away from some of that legacy-based language. Data sources, functions, interceptors, modules, and schedulers. So these services are kind of the core underpinnings of what powers the BoxLang runtime, but they're also documented and available to your applications running on top of them, so you can kind of tap into them to give you extra functionality. And then, of course, we kind of call them the global services. So that's a pluggable system. You can actually contribute your own services to the BoxLang runtime. So the runtime allows you to say, get the name of my service. So if you're writing a module like our ORM module, it provides an ORM service that's available globally with loggers and interception points wrapped around it. So the goal is to really give you flexibility to scale the core language itself at the runtime level in ways that you've never been able to do before. We also have a multi-parser setup where we've built two different Antler parsers so far, and we're going to build more coming soon. And so we have a parser that parses our BoxLang syntax, which is basically a new language that's based on all the really good parts of CFML that we liked, but fixes all the little things we wish had been done differently over the years, right? But then we also have our CFML parser that parses CFML exactly as it's defined today. And the goal is that both of those parsers create the same AST or abstract syntax tree, and we like to call that BoxLang abstract syntax tree, or BLAST. So that's the consolidated representation of if statement, assignment statement, plus operator, right? All that code is represented. So it doesn't matter if it starts in tag, or if it starts in script, or if it starts in box script or CF tags. Whatever parser is invoked based on the file extension, we parse that representation, and then we go to bytecode. So we generate the same bytecode at the end of the day, regardless of what the source was that we parsed. And that gives us a lot of flexibility, and we already have plans to be able to build parsers for things like COBOL or other languages to be able to bring those in and run any language on top of our core. As long as you can create the AST, the representation of a code, we can turn that into bytecode. So the BLAST is really core to a lot of the functionality of BoxLang, and it's something that we never had access to in the past. One of the huge missing pieces of functionality in the Cold Fusion space was tooling, was static code analysis, was code coverage, was linting, and there was tools like Code Checker, but those were all just based on regular expressions, and they may work on script but not on tags, or vice versa. So the intermediate representation of everything your source code is in this AST, or abstract syntax tree, is the foundation for all of our tooling. It's what powers our LSP. So when you open up a CFC or a BX file on our VS Code extension, we can immediately underline syntax errors because we're parsing the code on the fly via the embedded BoxLang runtime and parser that's powering the LSP. And we're not having to rebuild our own regular expression-based parsers for that. We're just using the actual parsers built into BoxLang. Our transpiler, which can take Cold Fusion code and spit out BoxLang equivalent, is based on this. We have all sorts of code quality metrics and code formatting and tooling that we have in progress to be able to automatically report on missing query params, report on missing var scopes, any sort of code linting. If you want to look for functions with more than 15 arguments and you want to underline those as a problem in your application, we can do that by writing visitors that visit the AST. So that's something that's really always been missing, and a lot of companies come to us and they say, we're the second-hand citizens at our company. Our Java developers have all these tooling and we have nothing. And so that's what we wanted to be able to provide going forward with that. So this is our way to kind of, bring in a new language without having to break things. That way we can leave the definition of CFML as Lucy and as Adobe define it, and then we can innovate over in the BoxLang parser without having to try to create two languages all in one. We have a transpiler, which will take your ColdFusion code and convert it to BoxLang if you want to play with some of the new syntax features. But the BoxLang syntax is a new clean slate, and this gives us a fresh language we can go market to Java developers that already has an ecosystem of all the goodies that exist in the CFML world that are out there on ForgeBox or whatever. It's very hard just to create a new language that has 0 frameworks, right? That allows us to run them both together. The compiler for BoxLang has seen a lot of changes since last year. Our very first iteration of it was very slow. It went to Java source code and then ran that through the Java compiler, and everything now is going straight to bytecode. So we parse it, we create the AST, and we go straight to bytecode. It's much faster than it was a year ago. Starting up a ColdBox app only takes seconds now as opposed to minutes. And we even have, as a first-class citizen, our BoxLang compiler CLI tools. So you can pre-compile applications before you deploy them. And if you looked at my SocketBox demos I put out a few months ago, I have running on render.com on their free tier. I used our BoxLang compiler to pre-compile those so they would be very fast startup times. Coming soon, we're going to be building the compiler into our IDE tooling and packaging, also the ability to create class files, and even package up an entire application as just a jar file that you can run. So we really want to focus on the build time optimizations and pre-compiling to be able to have nice, tiny, fast deployments. Another big innovation is the event-driven language. This is something that we leaned into a lot in our ColdBox framework and our ContentBox framework, and this is the idea of interceptors that can listen to events. And this is where our flexibility and our extensibility comes from, making the core of BoxLang just as tiny as possible with as little functionality as possible, and then modules which can reach into the core and contribute behaviors, contribute functionality, change how the behaviors work. That's all available via interceptors. So as an example, every time we create the server scope in BoxLang, we announce the on-server scope creation interception point. And our compatibility module listens to that interceptor and says, oh, compatibility is turned on and you want to be compatible and present as a Lucy server. It injects the Lucy struct into the server scope. That way the core of BoxLang doesn't need to have any logic about that. The compatibility module can just reach in and make that change at runtime. And so it's a very powerful way to scale the language. And of course, you can write your own modules that reach into the core of BoxLang and change how things behave, add your own built-in functions, add your own tags, add your own services. So there's a lot to play with there. And I can talk about that in my session I have today. So BoxLang aims to be a modern and dynamic language. We started with the Java 21 as the minimum version. We didn't want to worry about supporting the older versions of Java. There's a lot of new features in Java. Oracle's done a lot of good work. So starting there as a base minimum gave us a lot of things to work. We're fully JSR 223 compliant. As is Lucy, very nice. You can take, BoxLang, drop it into another Java application, run BoxLang code. Allows for great interoperability. We also avoided using Java Reflection. That's a very old API from Java 1. Invoke Dynamic has been around since Java 8, and that's the way that Oracle provides for dynamic JVM languages to call methods and access fields dynamically at runtime. And everything we built in BoxLang is built on top of Invoke Dynamic. We have our entire dynamic object framework, in fact, that wraps that up. We support all the automatic casting, promotions, even contagions of types, handling things like floating point math and very large numbers. automatically we promote those to integers, to longs, to big decimals, but we've optimized it to use the smallest possible number that won't lose any data. So if you declare the number 5, we store it as an integer because it's all it needs to be. You add that to another integer, the result's an integer. You divide that by a big decimal, now the result's a big decimal. So all this happens behind the scenes, and it's very smart to keep it as small as possible until it needs to promote. We also are using all sorts of new JDK features. We're using records, pattern variables, many features of a JDK that are available in the later versions that we can use because of our minimum version. And of course, the direct to bytecode compilation is a huge benefit over what we had last year. We've also announced native YAML support. That's something we wanted for a very long time. There's lots of libraries out there that do YAML manipulation, and so we have a module, of course, that gives you a YAML serialize, YAML deserialize, and deserialized file. So this is just one of the many modules you can install into BoxLang to get functionality for dealing with YAML. And then our Java interop has been a main point of new features that we've really felt held back in the past interacting with Java libraries. We've wanted to have more functionality there. So our goal is to be able to interact with Java very naturally. You look at almost any JVM language out there that exists today, and they can just say things like new JavaLang string, right? They don't have to have any other wrappers to do that. So we have the ability to import Java classes directly. You can implement Java interfaces directly. You can extend Java classes from your classes directly. You can also execute BoxLang within Java and Java within BoxLang, so you can go either directions. We've implemented the idea of object resolvers, so the new keyword can now be used to create either Java classes or BoxLang classes, i.e. CFCs, right? So we've added that integration at a very low level, and it's even extendable. You can have your own custom Java resolvers. So when I import JavaLang system, actually that's a bad example because that's a static. If I create new Java util hash map, right, I'm just creating a Java class directly, and the new keyword is now powerful enough to be able to create either Java classes or BoxLang classes. If I import JavaLang system, I can statically reference system out println, get properties, and of course, we also have a very new tight integration with Java lambdas. A lot of, even the JDK and Java frameworks are using functional programming and lambdas, and that was always a real pain to interact with in the past. You had to use create dynamic proxy, you had to create special CFC wrappers, and all that just works out of the box now. You can take a closure or a lambda in BoxLang, and you can just pass it into a Java method expecting a functional interface, and we just make it work behind the scenes. So in that last example, I'm actually interacting with Java streams from BoxLang. So I create a hash map, get the values, create a stream, filter it with a BoxLang lambda, find first or else. So that's just the Java stream API, but we're interacting with it directly in BoxLang as though we're writing Java code. So it's very nice, makes it so much easier to integrate with third-party modules, and we even have the ability to import classes directly from modules. So we've modified the import keywords. You can alias imports. You see I have importing Java util date as JDate. That's a nice new syntax, and you can even say import the class from a particular module. So lots of enhancements there. Our file formats, we have the BXS for BoxLang script. We have BXM, that's a typo on the slide, for BoxLang markup. And then our class files or CFCs are just BX. And we've also made some opinionated decisions. We've said we think classes should only be in script. Hope that doesn't make anybody angry. Don't worry, if your CFCs are in tag, our transpiler will convert them to script for you. So we're trying to push the language forward in some ways that maybe have some opinions, but we think make it more palatable as a new language. And all of these are runnable from the operating system. You can create a class with a main method, and you can just type BoxLang myclass.bx, and you can run those from the operating system. We have a modern null behavior is on by default, unless you install the compat module, in which case we'll turn it back off. We have a new cast as operator, a new instance of operator. We have a new annotation syntax. You can see some of the examples, like I have class, you have at singleton. It does the same thing as the inline annotations do, but it's just a more familiar syntax from languages like Java. It gives some more flexibility. We have an assert statement, which is common in many other languages. And we even have things like the multi-catch blocks, where you can catch multiple exception types all in one catch block. So lots of little changes, and these are things that are all in the BoxLang parser. So you can't do any of these in a CFC file, because that uses the ColdFusion parser. You can convert that over to a BoxLang, and you can play with these new syntax features. We also have a bunch of functional wrappers. We love functional programming. We even got some crazy ideas from Sean Corfield, who uses Clojure and gave us some ideas to work on. One of my favorite is the ability to wrap up a BIF or a built-in function as a function of its own. So on the first example, I have an array of data, and then I want to map each item in the array and just uppercase them. So instead of having to write open, close, parenthesis, color, arrow, ucase color, I can just do colon, ucase, so we pass in a functional wrapper to the uppercase BIF that's built into the language, and that becomes the higher order function we pass in. So very nice, tidy syntax. You've never been able to reference a BIF as a variable before, right? You can also reference Java methods. So if I import JavaLang system and I get a static reference to the out and then the println method, I can just pass that method into the each method on an array and print each item in the data out to the console, right? So there's no wall between a Java method and a function in BoxLang. I can just intermatch them and everything works. We can also do the same thing with, that's a static reference, so I can get a reference to the add method in a hash set, and I can pass that in as a higher order function. And we even have a nice little object invoker. So instead of having to declare, a little closure s arrow s.trim, I can just say .trim, and for every object that we map, we just call the trim method on it. So that's an idea we got from Clojure. It's a nice little syntactic sugar that just makes your job easier as a functional programmer. So BoxLang has been modular since birth. We did avoid OSGI. There's a lot of benefits to it, but we found a lot of things we didn't like about it. So we took the things that we liked and we built our own library where we still use individual class loaders per module to keep those separation of different Java libraries not colliding with each other, but we've done it on our own without OSGI. So you can write modules in Java, but you can also write them entirely in BoxLang. So if you want to be able to add your own built-in functions to the language, add your own tags to the language, you could do that entirely in BoxLang. And my session today at 4:15 is on just that. So I won't spend too much time on that. I'll show you how to write a module, how to install it in just seconds, and how to contribute to the language. We have mappings. There's all sorts of automatic things. It's very much by convention. And if you've ever written a module for ColdBox or for ContentBox or for CommandBox, it's very, very similar the way we've laid it out. So we have tons of modules. We have, I think, over 30 modules that are all, we have open source modules, AI, ORM, SAPI, Image, FTP, Jython, a bunch of JDBC modules that are all already written. And then coming soon and already in progress are our commercial or enterprise modules for plus and plus plus versions of BoxLang, which includes some of the cache connectors, AI plus functionality, things like that. And of course, if there's anything that we don't have, you can help contribute those. If there's a functionality that you've always wanted or something that we haven't written, like CF chart, because we don't really use that anymore, you can help provide that. And we even have a module template, I'll show in my talk today, that can get you started with a repository you can clone, and it has the template of an empty module and says add your built-in functions here, add your interceptors here, and you can be off extending BoxLang. So I'll cover that later on today, but you can publish those very easily to ForgeBox in just a matter of minutes, and then anybody in the world can install your module into their BoxLang server, and they can share in whatever functionality you've written. So our goal is to really build a community of people that can come in and help extend the language, help work on stuff together, because we love open source. So if there's anything we haven't implemented yet and you can talk to us about sponsoring that, or you can talk to us about helping build that yourself. That's our goal, is to be able to have the community come together and do this. The async framework is also a super cool thing we've been working on. We have a scheduler service. We have an idea of schedulers and scheduled tasks. Luis mentioned those earlier. It's really nice. You can just have a command line that just starts up a schedule and runs in the background. We have our async service, which has the idea of executors. And then we have our own boxed future object, which extends the Java completable future. So we've wrapped all that up and we've built it into the framework. And we've also added support for virtual threading, which is a super cool feature that came in like Java 20 or something. I forget when they finally made it stable. 21, okay. But virtual threads are a really cool newer feature of Java that allows them to separate the thread in the JVM from the native process thread at your operating system level. And in the past, if you created more than a few thousand threads in a JVM, you would basically crash the JVM. You would take up so much memory, it would fall over and die. With virtual threads, you can create 1 million of them, and it does sharing with them where if the thread needs CPU, it matches it up with a native thread on the operating system. If the thread's waiting for I/O, it gets stuck off on the shelf. And so you can have literally 1 million virtual threads without the JVM crashing. So we have support for that already. We have the ability to run them synchronously, asynchronously. They don't compete the same for the processor. They're able to be set aside when they're waiting for I/O. And they really provide great throughput if you have I/O-based processes. So some sort of import that does a lot of database calls, you could spin up thousands of threads doing that, and they won't compete for the same resources the same way. So you can use them right now with the thread component just by setting virtual equals true, and you interact with it the same way you would any other thread. We also have added, next slide, some nice new BIFs like thread new, where you can just provide a closure for the thread, and you just get back a reference to the thread, and you can say virtual true, and you'll get a virtual thread. And then we even have some pre-made executor pools, which are basically just pools of threads. We have an I/O one, which is our virtual threads. We have a CPU-based one, and then one for scheduled tasks. So these are already built into the language. And then whenever you do parallel tasks like array.each or struct.map or query.filter, these behind the scenes are using Java streams, which run in these executor pools already defined in the JDK. So there's a lot of power and configurability there. Like I said, Java's made some really great improvements in how it handles threading, and we've been missing a lot of those in our ability to use at the Cold Fusion level. So we're bringing that into BoxLang. Our boxed future extends Java's completable future. It's used for asynchronous fluent pipelines. It's basically threading on steroids. So we can say, run async, provide a closure with some sort of processing, and then we can chain these nice fluent methods or timeout after 5 seconds. And when that's done, then run this code. Then log out some information, right? Dot on error. If it errors, it fires the on errors. It's a really nice Fluent API, and this is all part of the JDK. Java's had this for years, and it's never really been available in an easy way, and so we've elevated that up directly to our box future class, and we even have some built-in BIFs now, future new, future all, run async, attempt. These are all kind of first-class citizens of the language to give you a lot more power than we've had in the past. And then, of course, we have a whole bunch of new BIFs. Attempts is based on the Java optionals. It's the ability to try to perform an action that may or may not succeed. And instead of having to deal with, do I get null back, you can get a nice fluent object you can call methods on. We have a bunch of new threading, asynchronous, and then even ability to control the executor pools or the thread pools that are built in. So all this stuff has existed for years in Java, but it's not really been accessible to you. And we've really tried to lean into that. So lots of cool architectural stuff. Like I said, I'll talk a lot more about modules in my session today, so I kind of skipped over that. But for now, I'm going to give you back to Luis to talk about tooling.
Cool. All right, so tooling. So one of the things that we found out is obviously we needed a lot of more tooling, right? So we started the BoxLang IDE. So Mr. Jacob Beers on the team is the lead for this, and this has been on a very fast iteration life cycle. We've done so much since we presented this last year. The LSP has become an official runtime for us. We provide code insight and highlighting. We're adding inline documentation now already, the mini server that I'll be showing you. And of course, you can run any type of CFML or BX code and the built-in debugger. There's a more polished experience now. You will see that we have a dedicated panel for BoxLang now. The REPL has been integrated to open right there in VS Code. Quick access to anything in the community, and ability to check out all the different runtimes that you have available, or you can actually add runtimes into VS Code. We've integrated the majority of the commands. More are coming, but this will all be available into the IDE so you can basically run them. So we're adding the capability, like Brad said, about the compiler. So in the background, we're going to be able to actually compile your classes in real time and give you feedback in real time and packaging in real time. So there's a lot of functionality that we're building into the IDE that was not possible before. We've also, since the last year, we've added a home manager. Like I said, this is ability for you to manage your runtime homes. Not only your operating system runtime, but anything, whether it's managed by command box or a mini server, you have available to it to view the logs, to manage the configuration, clear the class files, important one, and manage and install modules right from VS Code. We also added the capability to manage different versions. So if you want to test actually something in a specific version, you can very easily. So you can just choose which version you want to test, and now everything that you run in VS Code is now going to be with that version. Mini servers, operating system, etc. It really is a game tester to test for regressions. And of course, the debugger. The debugger has gone through a tremendous amount of iterations for us to really compete with other languages. So we added the ability to do breakpoints that we showed off last year, but now you can actually integrate natively with the operating system, the mini server, and command box. You can pause threads now. You can move threads up and down in the call stacks. You can change variables at runtime now. So if you actually want to test a specific value of something, you can change it. And I'll show you how. You can do variable expressions for watchers now, conditional breakpoints, and you can live debug any BoxLang enabled server. So let's see if it works. So always problematic. All right, so you'll see now that we have our BoxLang little icon here. We have the ability now to manage your servers, the different BoxLang homes, help and feedback if you wanted to open a REPL, okay? We have the capability now to do diagnostics. So if you actually open a file and it was determined that it was supposed to return a string, but it returns a numeric, now it'll tell you, hey, why are you turning a numeric here, right? So we're trying to give you all this insight now and provide even the problems panel with capabilities so you can start populating them. And this is going to be configurable of how annoying it can get to you, okay? So it'll be up to you to annoy your people, right? So that's one thing. The other thing is that since we're in the age of AI, we've created a BoxLang chat component right here as well. So you can say, okay, how do I define data sources in BoxLang? And it's basically aware of the BoxLang documentation. And it will actually inject all that into the project and basically, okay, you say, yes, I trust you, okay? And it's gonna start telling you, okay, to define a data source, this is how you do it. It'll give you even code right now to actually help you with this. Or if I can say, how do I call a static method, right? It'll basically tell you, okay, this is how you call a static method, right? So it'll work with generation as well. It's still, this is on experimental. You have to be on the pre-release. But this is going to be integrated in cursors as well and in VS Code. And this will allow you to basically teach this LLM about how you code on BoxLang, and it will integrate all the Java API docs as well. So you can get into the Java systems as well. So all that is available as pre-release for now. All right, so I'll show you a little bit about the debugger here for the operating system. Well, first of all, we look at scripting here, for example. If we have a task, you will see now that when you have a task or any class that exposes a main method, you will now see a run method right here. So this basically allows you for the LSP to detect that this is a runnable class, and I can click it and it will say, okay, what arguments do you want to pass into it? And it'll run, and basically right there it ran the class for me, right? So all that very easily you can start in the IDE working with CLI apps if you wanted to, or even just a quick test of something that you're building on a CFC. You can add that with the main class. So that's another improvement from last year. We'll add a little bit of breakpoints here, okay? And let's run this guy. Okay, so as you can see, it's extremely faster now. Okay, it's almost instant. And you can see here, basically, I've created my breakpoint on B++ here. It gives me my stack.
Make it bigger.
Better?
Enhance. Enhance.
It gives me all my scopes that are available in this situation, right? Here's my variable scopes. There's B++, it's B42, right? There's A, there's hey, hello, right? And I can continue now. I can say, okay, continue. There's my B+. It's going to uppercase my A number 1. So you can see here, A number 1 is Luis, right? But if you know what, if I want to mess with this and I want to call myself Luis, but I want to call myself Jorge, I can actually change the variables now, right? And it will interact with the change that I've done, and now you'll see that it changed it to Jorge, right? So you have the capability to pause these threads now and go to the anything expression here and actually change those variables to see how you can match a bug, for example, that you're trying to fix, or do different iterations of what your code should react depending on the input, okay? And of course, then you can continue executing your requests until basically you finalize it. And there you hit the next breakpoint, and then you can finalize the request. So, game changer for a lot of things for us, right? Conditional expressions was something that we wanted to do. So you can now click on a breakpoint, and you can edit the breakpoint. And now you can basically type an expression. So if this is a dynamic expression, you can put in the dynamic expression of when the breakpoint should hit. You can do when something is hit so many times. Okay, if you actually had hit this breakpoint 50 times, then break. Or you can actually log a message every time the breakpoint is hit, right? Or you can just wait. So there's a lot of more options that we've done with the debugger. I can't show you all of them in this small amount of time, but play with it. I mean, this is something that we've never had, and sometimes I just sit there like a nerd watching variables. But we've done a lot with the IDE. To give you another demo with the mini server now, what we've done is that you have the capability now to integrate with the mini server anywhere in your project. You can right-click now and say, okay, I want to actually run a mini server right here, right? So I can say I want to run a mini server, choose the port, and there it is. You see how fast that ran? That's it. It's started, and the application is running. This is how fast you can start with the mini server, and I just created a brand new little server there. There's my application running on the mini server, okay? I can open this application right here. You can see it's a very simple one. It just says hello from BoxLang, calls a BIF, a few things, but you know what? Let's debug it, right? So I'm gonna debug the today right here and say I want it to stop right here on the today and on the print lambda. And then in order for me to debug it, I can go to my panel. Here's my mini server that's running. It detects that it's running, and I say, hey, I want to debug it. So I attach the debugger to the mini server, and now I'm in debug mode. So now I can go here and hit refresh, and now I'm in my breakpoint. So very easily now I can start adding debugs. I found a bug, I want to start the debugger, and I want to do breakpoints and solve the bug. I can move on, go through it, hit my next breakpoint, finalize it, and then I'm done. Okay? So this is also available for command box. It's a little bit tricky still with command box, but this flow will hopefully come soon for command box as well. Okay. All right, so this is just a sneak peek of the things that you can do now that's available for you for CFML and BoxLang. So you can debug CFML as well. And like I said, we also released the documentation for this. We love the documentation. So you can go to BoxLang-IDE, Ortus Books, and now everything that we're doing in the IDE is going to be here available for documentation as well. This is something brand new. We still are in the works, but now you can extend the IDE via BoxLang modules as well. So we really wanted the ability to be able to extend VS Code without doing TypeScript or JavaScript, and now you're going to be able to. So now you can create your modules in BoxLang. You can be able to publish your own diagnostics, do your own formatting. We'll create the AST visitors for you. It'll suggest autocomplete options according to your library, right? Do code quality, anything that you wanted, and you're going to be able to distribute those packages via ForgeBox. This is still in the works. It's still not documented, but it's coming pretty soon. So like Brad said, the tools was super important for us in order to really go compete with everybody in the world. So we have even more things that are right now in development. Dynamic variable insights, since we're in a dynamic language, You're going to be able to provide dynamic insights by doing inference on depending how the code executes, IDE hints, static analysis, IntelliSense, code formatting. API docs are going to be integrated with a help viewer. And the test box extension is going to be integrated as well as an external module. So lots of things that we're working here with the roadmap. A lot of people have asked us, where's the admin? Where's the admin, right? They want to see the admin. So we've been working with the admin, and now we have something I get to show you today. We've actually built it with BoxLang. So this is our new runtime using Electron to integrate with the mini server. And the entire admin is built on ColdBox and reactive UI using CB-Wire. Okay? So let's see if I break it. And I broke it because it's stuck. Maybe I can't show you anything. Ooh, my computer's stuck. There we go. Oof. All right. So here's, let me move this out of the way so you can see it. Okay, so this is the administrator. This is running our mini server and ColdBox and CB-Wire. It's super alpha, and this will eventually be in your dock up here. And the idea is for us to be able to manage. Oh, now you're expired. Right, at least that worked, right? So this is the new administrator for BoxLang. So this will actually tell you the desktop operating system that it's installed, the information about installation, if you have a premium account or not. You can get into auto updates from here. You can manage the entire operating system runtime from here, from the runtime behaviors, scope behaviors, class settings. Everything that's available in the BoxLang.json has a UI now available to you, okay? So you will be able to manage the operating system runtime from here, but we've also, for subscribers, added the ability to manage all your command box servers from here, manage multi-site SSL certificates, even generate your SSL certificates, and all that will be available from the command box servers. You also can manage any a la carte runtime. So if you're building Lambdas, or you're building Android apps, or you have a Java app with BoxLang, you can basically come in here and add all the different registrations of that runtime, and you can manage it from here in the same approach, okay? So this is what's coming to you really soon. We're finalizing everything. We are working on this, so hopefully we'll have it in the next quarter or so. But we're also going to be releasing, and of course, the Electron runtime. So you can create your own desktop applications very easily with BoxLang. This has been definitely a fun little project. So to kind of finalize and start the day for us here at CFCamp, just a little bit of where we're going for the future. Obviously, this has been 20 months in the making. I'm so happy that we're finally here, and we have a 5-year roadmap of everything that we want to do. Basically, there will be a major release every May at Into the Box. Every minor release comes pretty soon as well as needed. We'll try to hit every minor every last week of the month. Patches, of course, a la carte and security as soon as possible. But this is something that we're sticking to, and hopefully help people to have confidence in how they're going to get their patches. Like I mentioned before, we're completely professional open source, just like ColdBox, like ContentBox. This has been our ethos is to help the community with this, and this is the same idea, but obviously there is a commercial aspect to it if you wanted to, with our subscriptions, with no types of silly restrictions. So you can do BoxLang Plus or Plus Plus. There's differences in some of them. There's all documented for you. If you have any questions, you can ask Jorge. Okay. He's in charge. But this helps out the project to keep it alive as well, and you can find all the plans online as well. Oh, but wait, there's more. Mark Drew loves that one. There's more. So we released a few weeks ago a new initiative called learn.boxlang.io, which is our BoxLang Academy. So this was inspired by our CFCast's product. So these are a video learning tool, and it is completely free for 1 year. So we're going to be putting all the BoxLang videos, everything that we do for learning how to work with BoxLang and CFML is going to be on learn.boxlang.io, and you're going to have access for free for 1 year. And then obviously it becomes a subscription model just like CFCast, but this will hopefully help the community and start learning with BoxLang. So we're excited about this initiative as well. And of course, if you want to run your applications already, you can. We have BoxLang cloud servers deployed now. So you can do it in AWS, you can do it in Azure, or you can do it in Google Cloud. 25 cents an hour. You can go to BoxLang.io and hosting. We'll take care of you. We'll help you with everything that you need in the cloud. And it's available as a turnkey solution if you wanted to start really quickly with your production instances. You can either run command box, you can either run a CLI version, or you can run the mini server. So with that, we're super excited to be here again. We have been working very hard, and hopefully you guys can start out and give us feedback of everything that we're doing. And we can't wait to see what we bring next year. Thank you.
Wow, we never had this before, that someone stopped 15 minutes before his time. Could someone please...
You warned me.